Good morning, students. Today we are going to learn about the rate of change. What is the rate of change? A rate of change is a rate that describes how one quantity changes in relation to another quantity. For example, if I am taking an equation y equals to x to the power 3, then the value of y will be depend on this value of x. That means this x is called independent variable because we can assign any value for x. But y is called dependent variable because it depends on the value of x. For example, if I am taking a car is moving from one place to another. That means I just consider those two as a point A and B. A car moves from A to B. So that is called a distance, a car traveled. So now if I am taking the time, then at the point A and at the point B, the car slows. But in between, there is a lot of changes in time. So that means that smaller changes, maybe it is 1 minute to 2 minutes or 2 minutes to 5 minutes. So like that, that is called the rate of change. Okay. So supposing if I am doing or calculating all these things in a graph, then if on a graph I am taking time as x-axis and distance as y-axis, then if a car moves in 2 hours 60 kilometers, in 4 hours 160 kilometers, then we can get a direct variation here. This is called a velocity. So v of t is equal to ds by dt. So what is that? Yes, that is the velocity is nothing but there is a change on the displacement according to the time taken. Supposing I take acceleration, then a of t is equal to dv by dt. It depends on the velocity in the form of time taken. Now we are going to look at average velocity. What is average velocity? F of b minus f of a by b minus a. That means a car moves from a to b. Then there is two values, that is a and b. Therefore, we are substituting that on the function f of b minus f of a. Now we are going to look at the instantaneous rate of change. So what is the instantaneous rate? So instant. So at that particular time it will taken. Therefore, instantaneous rate of change dy by dx at particular time x is equal to t seconds we can take. So now I just give you some more examples where it applies. Supposing we are considering a population, the growth of population will be taken according to the time taken. So at what time the number of people will increase or decrease. So but population will surely increase. And another example is rate on the production. So according to which time or year or month, whatever it is, so the number of goods, that is the production, increases or not. So increases or decrease, it may be vary. And again, one more known example. We know that while the cyclone forms, they will announce us. So at what time it reaches the land, or what is the rate of changing its position. So like that. So the rate of change is used to find the position of the cyclone also. Now we are going to look at some more problems. So now the first problem is a point moves along a straight line in such a way that after t seconds, the distance from the origin is s is equal to 2t square plus 3t meters. So what is given to us? There is an equation given. S of t is equal to 2t square plus 3t. Find the average velocity of the points between t is equal to 3 and t is equal to 6 seconds. So there are two things given to us. So t is equal to 3 is A and t is equal to 6 is taken as B. We are going to find out average. So first I am going to substitute the point. So S of 3 is equal to 2 into 3 square plus 3 into 3. If I am simplifying this, then it becomes 3 square is 9. So 18 plus 9 equal to 27. Then I am substituting t is equal to 6. So if I am substituting 2 into 6 square plus 3 into 6. If I simplify that, then I will get the value as equal to 90. So now I am going to find out what is average velocity. So average velocity is equal to S of 6 minus S of 3 divided by 6 minus 3. That is, we are substituting those two time taken. If I am simplifying that, then I will get the value equal to 21 meter per second. That is the average velocity. Now we are going to find out what is instantaneous velocity. So what is instantaneous velocity? Directly at the point, corresponding point. So two things are given to us. T is equal to 3 and T is equal to 6. So we are going to find out that. So instantaneous velocity, the equation is given to us. I am going to substitute the value. Before that I have to differentiate it. So S dash of T is, T square's differentiation is 2T. So it becomes 4T plus T's differentiation is 1 plus 3. So now I am going to substitute those 2 points. So now if 3 means 4 into 3 plus 3. If I simplify, I will get that is equal to 15. Now I am going to substitute T is equal to 6. So S dash of 6 is equal to 4 into 6 plus 3. So that is equal to 27. So these two are the instantaneous velocities. Now shall we look one more problem? So the next problem is nothing but if a camera is accidentally knocked off at the edge of a cliff 400 feet high. So the camera falls a distance of this is equal to 16t square in t seconds. So now here there is a cliff. The distance, that is the height of the cliff, is nothing but 400 feet. That is given to us. So now there is a camera which is placing on it and it falls down after that 16t square seconds. So what is the equation given to us? S of t is equal to 16t square. So now we have to find out how long it will be. So that means you have to find out the time taken. So I am going to equate that. Then 16t square is equal to, what is the total height given to us? 400. So that is equal to 400. If I simplify this, then I will get t square equal to 400 by 16. Then t square is 25. T is equal to 5 seconds. So how long it will take? It will take 5 seconds to fall down. So now this is the one. What is the second one? What is the average velocity with which the camera falls? So do the last 2 minutes. So last 2 seconds. Last 2 seconds means what is the total? 5. So therefore last 2 means from 3 to 5. That is the thing we are going to find out. Now we are going to find out that last 2 seconds value. So then S of 3, I am substituting that value. So first S of 3, then 16 into 3 square. If I simplify, 144. When t is equal to 5, then I am substituting. I will simplify and get the value as 400. Therefore, average velocity is, if we substituted in the formula, we will get it as 128 feet per second. So that is the average velocity at last 2 seconds. Now instantaneous velocity, exactly it is given. What is given? T is equal to 5 seconds. So I have to differentiate the given equation. So first I am going to take the given equation. Now I am going to differentiate it. Since we have t square, it becomes 2t, so 32t. Now I am going to substitute t is equal to 5. If I am substituting, I will get 160 feet per second. Now one more problem, let me see. If the volume of a cube of side length x is v is equal to x cube, find the rate of change of the volume with respect to x when x is equal to 5 units. What we have to find out? Rate of change. So that means I have to differentiate it. What is given to us? Given is the equation v is equal to x cube. I am going to differentiate with respect to x. So dv by dx equal to 3x square. So now we have to substitute the value x is equal to 5. So then x is equal to 5 means 3 into 5 square, that is equal to 75. That is the answer, we need to get it. Okay children. So if the rate of change is given, then we have to find out the differentiation and substitute it. Okay. Right. Now one more problem. This is a practicing problem for you. If the mass m of x, some thing is given to us, then you have to find out. This is the hint given to you. You have to find out the differentiation and substitute it.
Friends, can you tell me what Miss taught today? Yes, I'll tell you. A rate describes how one quantity changes in relation to another.
That means
That means, Miss said one example, no? Growth rate of population. A growth rate is the rate of change in number of people with respect to the time taken. Oh, then it's always the rate of change happens on time taken? No, 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 it is not like that. Even if you consider a slope, which is the rate of change in vertical length with respect to the horizontal length. That means if we divide any one quantity divided by the other quantity, then that is called the rate of change.
yes, of course.
Give me some more example, friend. Suppose if a rocket is launched, the velocity is the rate of displacement with respect to time.
And Miss also added the average velocity and instantaneous velocity.
What is the difference between those two? Average velocity means it should be happen with more than one item. So here we are going to find out the difference between two positions according to the time taken. Yes, of course. But the instantaneous velocity means what is the derivative of the L distance at that particular time taken. That is called instantaneous velocity. Okay, thank you, friends.
Thank you, children.